All right, Algebra 2. We are on Unit 3.5, and in this lesson we're going to be looking at how we can use synthetic division to factor a polynomial and also solve the polynomial, find the solutions, the zeros, roots, x-intercepts. They all mean the same thing. All right, so there are polynomials that don't factor, and well, in our general sense of the rules that we're allowed to use, they will factor, but we have to use synthetic division actually to help us get the factors. All right, so we will be using synthetic division, so make sure you're up to speed on using that method. All right, so if the factor x minus h, so it's a binomial, is a factor to a polynomial, then that means it divides evenly into the polynomial. All right, so when it divides evenly, that means that there's not going to be a remainder. So when we did our synthetic division and long division, if we were dividing and we got a remainder 0, that means that that binomial or whatever we were dividing into the polynomial, it meant that it went into it evenly. So for example, 2 is considered to be a factor of 10 because when we divide 10 divided by 2, we get 5 and there's no remainder, right? So 2 is a factor of 10 because there's no remainder. So if we have a binomial and it's said to be a factor of a polynomial, that means that if we were to synthetically divide into that polynomial, we have to get a remainder 0. Okay, so that's what it means. All right, so let's look at some of these. So we're going to be factoring these. So we have this polynomial, x a third minus 8x squared plus 4x plus 48. And so it is a 4-term polynomial, and we want to factor it, right? But it doesn't factor by grouping. And so I can show you why it doesn't factor by grouping really quick. All right, so we group the first two and last two. If I pull out a GCF, it's x squared, and I'm left with x minus 8. And on the second set, if I pull out a GCF, it's 4, right, and I'm left with x plus 12. Well, remember, in grouping, the two binomials that are left over have to match. They have to be the same. And they don't in this case. So this does not factor by grouping. It does factor, it just doesn't factor by grouping. So this is why we have to use synthetic division. So in this problem, they tell us that x minus 4 is a factor to this polynomial. It's one of the factors. There's 3 factors because it's a degree 3 polynomial. So we have to find the other factors. So since x minus 4 is a factor, that means it should divide evenly, or it has to divide evenly into the polynomial. Now, we could use long division if we want to use long division, or we can use synthetic. And synthetic is going to be a little bit easier because it's faster. So what we do is when we're given a factor already, what we have to do is change the sign of the binomial, so the number inside, change the sign, and that's what's going to go on the outside of the long division. All right, so it's going to be a positive 4. That's really key that you change the sign. All right, so then we put in each of the coefficients in order. Again, if you miss an exponent or skip an exponent, you got to put a 0 in. Don't forget that. All right, so that's the setup. And so now we're going to synthetically divide. So remember, we bring the 1 down, and then we multiply, and we bring it up. We add down. Then we just repeat the process. Negative 48. All right, and then we add down, we get a remainder 0. All right, so this tells us that we did it right. All right, so I'll put a little smiley face. All right, so you did it right if you get a remainder 0. All right, so now what we're going to do is write the new polynomial with those coefficients. So again, remember, we dropped the exponent by 1 from the original problem. Since the original problem started with x to the third, ours has to start with x to the second. So it's going to be 1x to the second minus 4x minus 12. So now what we can do is, since we've got it down to 3 terms, we could use the x method for factoring. All right, so again, if you remember, negative 12 goes on top, negative 4 goes on the bottom. Two numbers that multiply to negative 12 but add to negative 4, that's going to be negative 6 and 2. Right? So then the factors become x minus 6 and x plus 2. Right? So when the question tells us to factor the original polynomial, we have to give all the factors. So the factors are going to be x minus 6. Again, the order doesn't matter. X plus 2. And then the original one that they gave us as one of the factors, x minus 4. Right, so x minus 4, we'll just put it at the end. But again, it doesn't matter the order in which you put it. All right, so now this is the complete factored form to that 4-term polynomial. And we saw it didn't factor by grouping, but it does factor this way. All right, number 2, same thing. Let's see, so x plus 3 is a factor, so we have to change the sign to negative 3. Right, and then the coefficients are 2, 11, 18, and 9. And then we'll bring down the 2. We'll multiply negative 3 times 2 is negative 6. Add down, it's 5. Multiply negative 15. Add down, that's 3. And then multiply it's negative 9. And we get a remainder 0. We get it right. Put a smiley face. All right, so now we're going to write the new polynomial with those coefficients. So original one started with x to the third, so ours will start with an x to the second. So 2x to the second plus 5x plus 3. So we have the trinomial, and again we use the x method. Here we have to multiply the 2 and the 3 together to get the top number, which is 6. And then the bottom number is 5. So two numbers that multiply to 6 but add to 5, it's going to be 3 and 2. All right, now, because we're leading off with the 2, we have to remember we have to divide those by 2. Simplify your fractions. That will simplify. All right, so the factors become 2x plus 3. Make sure you bring the bottom number up. X plus 1. All right, and now we'll go ahead and give the answer in factored form. So 2x plus 3, x plus 1, and then the one they gave us, x plus 3. So don't forget that one that they give you. All right, number 3. Here they give us x plus 2 as a factor, so we'll change the sign to negative 2. Our coefficients are 1, negative 5, negative 2, and 24. Bring the first term down. Multiply negative 2 times 1 is negative 2. Add down, it's negative 7. Multiply is 14. Add down, that's 12. Then multiply, that's negative 24. Add down, that's 0. Yay, get it right. All right, so our new polynomial, 1x squared minus 7x plus 12. Use x for factoring. So our two numbers, let's see, 12 on top, negative 7 on the bottom. And the two numbers are going to be, looks like negative 4 and negative 3. We don't divide by anything because we're leading off with a 1. All right, so it looks like our factors, x minus 4, x minus 3, then the original one they gave us, x plus 2. All right, number 4. All right, x minus 6 is a factor. So we change the sign. 6 is our number on the outside. Coefficients are 1, negative 3, negative 16, negative 12. All right, bring the 1 down. Multiply, that's 6. Add down, that's 3. Multiply 6 and 3 is 18. Add down, that's 2. Multiply 6 and 2, it's 12. Add down, remainder 0. All right, so the polynomial x squared plus 3x plus 2. All right, again, we use our x because we have 3 terms, 2 on top, 3 on the bottom. And looks like 2 and 1. So x plus 2, x plus 1, x minus 6. All right, so let's keep going. So number 5. All right, so now it says at the top, if a number h is a 0 or a solution to a polynomial, so we have some number, let's say it's 5, is a solution to a polynomial, okay, then its factor, x minus h, is considered to be a factor. All right, so that's what we talked about on the first 4 problems. If we know a factor is a polynomial, okay, the binomial is a factor to the polynomial, then if we change the sign, of the number inside. So if it says x minus h, we change the sign to h, then h is considered to be a 0 or a solution to the problem. All right, and so it works back and forth. So here it says in question 5, if 10 is a 0 to the polynomial, that means its factor x minus 10 is a factor. X minus 10 is the factor, right? And so they want us to find the zeros, okay? Not all the factors this time. So the zeros are the solutions. But to get the solutions, we have to factor it first. So 10 is a solution. So we're going to take positive 10. So we don't change the sign because 10 is the solution. The factor is x minus 10. All right, so we take positive 10, and we're going to synthetically divide. Right, and we should get a remainder of 0 because it's saying that 10 is a solution. 10 is going to get you 0 in the remainder. All right, so bring the 1 down, multiply, head down. Okay, so we'll just go through the process of synthetic division. All right, you can see we got a remainder 0. So if you are on these problems and you don't get remainder 0, that means your math is wrong somewhere. Most of the time it's going to be because you have the wrong number sign at the very front. Okay, the sign is wrong. So try changing that sign. Make sure that if they give it to you as a 0, you keep the sign. If they give it to you as a factor, you change the sign. All right, so now we're going to go ahead and factor this. We'll go ahead and write the polynomial first. So it's 1x squared minus 2x minus 8. All right, now we can factor it. Negative 8 on top, negative 2 on the bottom. So the factors are x minus 4x plus 2. So now if we set those equal to 0 and solve it, the zeros are going to be positive 4, negative 2, and then the one they gave us, positive 10. All right, so remember, this is a degree 3 polynomial, and there's going to be 3 solutions that we're looking for. They just happen to give us one of them. All right, so number 6, 1 is a 0. Find all the other zeros, okay? So we're going to use positive 1. Our coefficients are 4, negative 4, negative 9, and positive 9. All right, bring the 4 down and multiplying. Multiplying. Right, so we get a remainder 0, which is good. So our polynomial is going to be 4x squared. Now it would be plus 0x, but because it's 0x, we're not going to put it in. And then minus 9. All right, now we want to factor this. Well, this is just a binomial, 2 terms, and it's a difference of squares. And so difference of squares, remember, factors 2x plus 3 to x minus 3. So then if we set those equal to 0 and solve it, we're going to get negative 3 over 2, positive 3 over 2, and then the one they gave us, positive 1. All right, number 7 tells us negative 3 is a 0. All right, so here we use negative 3 on the outside. Our coefficients, 1. Now this one's missing x squared, so you got to be careful. Put the 0 in, and then negative 13, and then negative 12. Right? Really important you put that 0 in. All right, so it's negative 3, we got down, it's positive 9, negative 4, positive 12, and 0. Okay, so this is how you're going to get that remainder 0. All right, so let's go ahead and write the polynomial, 1x squared minus 3x minus 4. Go ahead and factor it. Negative 4 on top, negative 3 on the bottom. So negative 4 and positive 1. So the factors are x minus 4, x plus 1. All right, and now we want to go ahead and find all the zeros, the solutions. So the solutions to this are going to be positive 4, negative 1, and then the one they gave us, negative 3. So make sure you know the difference in how you write it between what a factor is and then what a 0 is. Okay, factors are the binomials with the parentheses. The zeros are the solutions from the binomials when you set them equal to 0. All right, number 8. Given some polynomial, they give you a factor, okay, a binomial, and they want to know, is it a factor? Okay, is it a factor or not? So the only way it can be a factor is if you synthetically divide, or if you did long division. But if you divide the binomial into the polynomial, you get a remainder 0. And so we're going to check each one of these real quick, and this helps you with that synthetic division process and with your basic math skills also. So we're going to synthetically divide each one of these and find out if any of them, one of them, two of them, or all three of them, are factors to the polynomial. Right? So we change the sign because they give it to us as a factor, binomial, so it's going to be positive 2. Right? And so coefficients are 2, 7, negative 28, and positive 12. Right? So remember, we're trying to get that, see if we're going to get a remainder 0. Right? So bring the 2 down, multiply, that's 4, add down, it's 22. Add down, what's that, negative 6, multiply, it's negative 12, and we've got a remainder 0. So yes, we can say that x minus 2 is a factor to the polynomial. All right, now we've got to check the other ones too, because there could be more than one. So now we're going to try the factor x minus 6. So we change the sign to positive 6. Right. And then the coefficients stay the same. Right, so just do the process again. That's 12. That's 19. That's 6 times 19. That's 54. That's 114. All right, and then we subtract 114 minus 28. Just get the calculator real quick. It's 86. 86 times 6. 516. And you can see that we are not going to get 0. All right, so you could stop, but I'll just finish at 504. All right, so you can see the remainder is 504. So that is not 0. So x minus 6 is not a factor. All right, and then let's try one more C. So the factor is x plus 3. We'll change the sign to negative 3. Coefficients stay the same. All right, so bring the 2 down. Multiply, negative 6, that's 1. Multiply, that's negative 3. Add down, that's negative 31. Multiply, that's going to be 93. And you can see that you are not going to get a remainder 0. So, stop it there. We know that x plus 3 is not a factor. All right, so that's how you use synthetic division to find factors and also zeros or solutions.